My name is Chris Ortiz, and today I'll be talking to you about the power of CO2. Now, CO2, or more commonly known as carbon dioxide, is a greenhouse gas that is mainly emitted through industry and transportation. Now, looking at this graph on the left, we see that in 2019, industry alone created over 35 billion tons of carbon dioxide. That's not very good for us as a planet because carbon dioxide goes into the atmosphere and depletes the ozone layer, which in turn can lead to global warming and other adverse effects on us as a planet. So, what are we trying to do to combat this issue? On the figure on the right, there's 10 different ways that the world's trying to combat this issue of carbon dioxide uh, use or emissions. So the one we're going to talk about mainly is number one, chemicals from CO2. And we see that it has a low cyclic, half cyclic arrow on it. That just means that the pathway used to make these chemicals is a cycle, meaning we take CO2, carbon dioxide, then do some sort of chemistry to create some product, and then use that product and break it down back into CO2 to then be used again. One of the main things that can be made from CO2 are polymers. Now, polymers are just long chains of the same chemicals. These first two up here are just common polymers that everybody knows, maybe not by structure, but by name. First one is polystyrene. Polystyrene is foam or styrofoam. We use that to package things, packing peanuts, things like that. The one on the right here is nylon. Nylon is mainly used in clothes. Everyone wears it. It's in a lot of clothes. Now, these two aren't made from CO2 chemistry, but these are just some examples of polymers, so people understand why polymers are so useful. This bottom one right here is polyketone. Polyketone is directly made from this CO2 chemistry, um, and it's not as big as these other two, but it's still very useful. It's um, high temperature thermoplastic, which can be used in automotives, and the automotive industry is another huge industry all over the world. Now, how does the CIC contribute to this type of chemistry? First off, the CIC is an NSF funded initiative trying to make sequence polymers through integrated catalysis from abundant feedstocks, in this case, CO2. So, integrated catalysis is the way we're approaching the use of carbon dioxide. So, I'll start by explaining this little figure right here. Let us say that this little orange sphere is CO2 and this black bar is some sort of catalyst. So CO2 can react with this catalyst to create carbon monoxide or CO to then react with a second catalyst and another chemical to make this chain of or to make the sequence polymer. Now, why would we want to do this in one reactor or just this type of chemistry? So the first one is economic incentive. If we're able to successfully do this chemistry on a small scale, we could do this on a big scale, which can then lead to the use of the CO2 chemistry, and then it's economically incentivized because this is all done in one beaker, meaning they don't have to store anything, they don't have to transfer anything, it's all done in one beaker to create the products they need. Also, by not storing this intermediate of carbon monoxide, it's safer because we all know that carbon monoxide is very, very dangerous. It's very toxic to humans. So overall, integrated catalysis will allow us to control everything in one beaker and not need to mess with the chemistry in order to be safer and also to create an economic incentive to try to use greener chemistry. That was my little spiel on the power of CO2 in integrated catalysis. Thank you for listening. I appreciate your time.